Let me show you how it goes, and hopefully it all makes sense to you. So let's do that. So let me share up the whiteboard here. And so the first thing I want to talk about is interval notation. So interval notation is just a way to describe an area of the number line. That's all. That's all it is. It's basically, so here, let me show you what I mean. So here's a number line. Right, so here's my number line. I've got 0 there, 1, 2, 3, etc. -1, -2, -3. Okay, so let's say I wanted to describe all of the numbers between 0 and 2, right? So one way you can do that is you can just draw a picture, right? Here's my number line. I can do, let's do this in red. I can do like from 0 up to 2. And then I just shade in all the stuff between it, or I usually just draw a line. You can, some people like to shade like this, or probably more neatly than that, but what can I say? I'm drawing on my screen. So that is all of the numbers between 0 and 2. Now, I have drawn solid dots, or squiggles if you prefer, on 0 and 2 to indicate that I want to include 0 and 2 in that. So if I think of all of the numbers in here as various values of a variable called x, then I could think of this as x being between 0 and 2, like that. And notice that I've got or equal to, I've got x is greater than or equal to 0 and less than or equal to 2. And the or equal to's indicate that 0 and 2 work. If I wanted to do it differently, like let's say I wanted to do, let's say -3 to -1, but not include the endpoints, then I might do this, right? I would do a little open circle, right, to indicate that I don't want to include them. So that right there, I'll call this guy y. And I'll say that y is between -3 and -1. Right, so that's two different areas on the number line that I wanted to describe. Now, this is kind of I don't want to say a lot of writing, but mathematicians like their shorthand, and since we've got this shorthand method, I want to show you what it is. So what you can do is, what we really want is we want some way to say, I want all of the things that are between two numbers, say -3 and -1. I'll do the y's first here. Oops, I apologize. I kind of messed this up. These should not be or equal to. I shouldn't have written or equal to's. That's actually what I meant there. Here, let me get my pencil back. And so if I wanted to describe everything between -3 and -1, I don't really need the less than symbols, right? It's understood that left is smaller and right is bigger. And I don't necessarily need to draw a whole number line. All I really need to do is tell you what two numbers it's between, right? And so the way you do that is by putting them in parentheses or brackets. In this case, it's parentheses because we use parentheses to go with the just strict less than, not or equal to, like the just less than. So you can have like -3, -1. And it's understood that this means the same thing as this, which means the same thing as this picture up here, right? We use parentheses to signify that we don't want to include the endpoints, and then we just say what the endpoints are, and everything in between it is what you're talking about. So there's another way to do it for the x's here. The x's, we can use square brackets. We use these brackets to indicate that we do want to include that endpoint. So here I want to go from 0 to 2. And so these guys mean the same thing, and it means the same thing as this, right? So that's interval notation. Now you can do, there's a couple more things you can do with it here. Let me make a new page so I have some more stuff to draw with. So for instance, let's say I had, I'll put the 0 there. Let's say I wanted all of the numbers bigger than 3 and not including 3. So there's 3. So I want things that are just bigger than 3. So everything to the right here. Now that doesn't have a right endpoint, right? It goes on to the right forever. And so, I'll call this one x as well. And so the way we write that is like this. So my left endpoint is 3, and I don't want to include it, so I'm going to put a parenthesis. And then my right endpoint just keeps going forever. And so the way we signify that is with an infinity symbol, right? Keep going towards infinity. Now, infinity always gets parentheses because you can't ever reach infinity. So infinity is not an actual number. It's more of a symbol that means just keep going that way forever, right? It's not a thing you can get to. It's just keep going that way forever. Similarly, here, let's I should have done this in blue and red again, but that's okay. So similarly, let's say I want to do like everything less than 0. So all the negative numbers and 0. So I want to include 0 here. So I'm going to make a filled in dot, and I'm going to go to the left. And I guess we'll call this guy Y. And so that one, I'm trying to describe the red area. So my left endpoint is infinity, right? But it's to the left. So we call that negative infinity because it's on the negative side of 0. So this just means go to the left forever. And it goes up to 0. That's the upper end there. And I do want to include 0. That's what the square bracket, or that's what the filled in dot means. And that goes with a square bracket. So you can have intervals, they're called open if you have parentheses and closed if you have a square bracket. So this is called a half open interval. It's called just an open interval. This guy here is just a closed interval. You don't have to know those names, but if you go much further in math, those might be relevant to you, but it's just what they're called. And that's interval notation. That's literally all there is to it. I suppose I should say something like this. The red here corresponds with y being less than or equal to 0. And the black corresponds with the inequality that x is greater than 3. Right, and so those are the inequalities that we've got here. And similarly over here, right? Like x is between 0 and 2. By the way, you can read this. Some people like to read this 0 less than or equal to x less than or equal to 2. That sounds very awkward to me. The way I like to think of it is that x is between 0 and 2. Inclusive. You say inclusive if you mean at the endpoints, or if you mean include the endpoints. Whereas this says that y is between -3 and -1. Exclusive, because you exclude the endpoints. If you don't say the inclusive or exclusive parts, that's okay. Just be clear about what you mean. Right, like, so I might say something like y is between -3 and -1, not including -3 or -1. You can also have finite half-open intervals if you want to. So for instance, if I wanted to do, let's do this one in blue. There we go. So let's say I wanted to include everything between -1 and +2, not -1, but do include +2. Of course, it's going to work just like you'd think. I guess I'll call this guy Z. We'll say that that -1 is the left endpoint and 2 is the right endpoint, and we don't want to include -1, and we do want to include 2. There you go. That's interval notation. It is just a way to conveniently describe areas of the number line without having to do too much writing. It's a shorthand way, I should say. Now, there is one other kind of fancy thing that you can do, which I will show you how to do as well, which is joining intervals together. So let's say I have this 0 here, 1, 2, 3, 4, 5, -1, 1, 2, 3, 4, 5. So let's say I have this one problem that I'm solving, and it turns out that I can have anything bigger than 3, but less than or equal to 5 as my answer, and also anything less than 1. So I want to think of this blue stuff here. We'll call this X. I want to think of this blue stuff here as all being part of the same solution, even though that solution comes in 2 pieces. So the way I can do that is there's a symbol called union that says take these 2 things and stick them together. It works with any set, but these are kinds of sets. So I would say my first interval here is -infinity up to 1, and my second interval is 3 to 5. So 3 to 5, and I'll use a square bracket on the 5. And the symbol that I use to put between them is this very plain uppercase U for you. And this means this is all one set, even though that set comes in 2 pieces, right? It comes in this piece and this piece. So all of this is one thing, even though that thing has 2 pieces to it. And that's the last thing I wanted to show you about interval notation. This is actually more general than interval notation, but it works in interval notation as well. And that's really all I wanted to say about interval notation. So let me talk about how to solve inequalities. Now, solving inequalities is pretty much the same as solving equations, except for one thing that we'll get into. But basically, let's say I have like 2x minus 5 is greater than or equal to 11. Right, so let's say I want to solve that inequality. I'm going to do it the same way I would solve an equation. So I'll add 5 to both sides. 2x is greater than or equal to 16. One thing to be careful of, you do have to be careful of which direction this thing is pointing. But as long as you are careful about that, it's really not any different. So I get an answer of x is greater than or equal to 8, which is a totally fine answer. Now, you can express that in a couple of different ways. You can show it on a number line. Right? I'm not gonna put in all the hash marks here, but let's say that's 8 there. I could show that on a number line like this. I could fill in that dot and say that I wanted everything over there. And I could also write it in interval notation. And the interval notation is 8 up to infinity. Right? So I want to go from 8 up to positive infinity because I'm going to the right forever. And I want to include the 8 because we had greater than or equal to 8, right? That means do include the 8, which is why I wrote a solid dot here and square brackets there. And it goes up to infinity, which is to the right forever. So that always gets parentheses, never square brackets. And those all mean the same thing. All of those are exactly the same thing. So this is a totally fine way to leave your answer. This is a totally fine way to leave your answer. And so is this. It'll turn out that this will have some advantages eventually for expressing kind of more complicated things. It can be a little bit easier to do it this way than that way. It's not the hugest deal to be able to do, but I do bring it up because a lot of math books do it this way, like to describe their intervals this way. And if you go much further in math, this will turn out to be very convenient. For right now, I don't particularly care which one you do, although I will ask you to do all 3 on a test. I want you to show me that you can solve the inequality, and that you know what that looks like on a number line, just to help you visualize it, and that you know what the interval notation version of that is. So there's one thing about inequalities that is different. There's actually 2. We're going to go over the. I think I'll just leave it at 1. There's one that comes up a little less often that we can talk about later if it's relevant. Basically, here's the thing. If you multiply or divide by a negative number, it ends up flipping the inequality over, and I'll show you why. So let's say I wanted to say that x was greater than 3. Right, that is 0, here's 3. That's this area over here. Now, let's multiply both sides of this by -1. That should be a thing I can do, given that the rules for inequalities and the rules for equations are basically the same. So if I multiply both sides of this inequality by -1, the thing I get is that -x is something with -3. Right? And so let's think about what that means for a second. So if x was over here bigger than 3, that means that x was like 4 or 5 or 10 or 100, right? It's something that's bigger than 3. So it's going to be like here, or here, or way over here somewhere, right? Those are potential values of x. When I take -x, this 4 becomes a -4. And this 5 would become a -5. And this 10 would become a -10. So I'm looking at things that are over here. right? So anything that's bigger than 3 when it's positive is smaller than -3 when it's negative. Right, so I'm looking at the things that are over here. What that means is that if x is greater than 3, negative x has to be less than -3. Right, so something that's over here, when you make it negative, goes way over there, goes past this -3. Right, so I don't want to say greater than here because that points to the right, and those are not the numbers I want. The numbers I want are to the left of -3. So all of this is sort of a long explanation to tell you that when you multiply or divide by a negative number, you get that flip over 0 thing, where not only does the sign switch, but the direction of the inequality also switches. So whenever you multiply or divide by a negative number, you have to flip your sign over. Now that's not true with addition and subtraction, right? So if I have, let's do the same thing, 0, 3, and so let's say we got x is greater than 3, so I'm looking at these guys. Let's say I subtract 2 from both. -2 minus 2, right? So x minus 2 is greater than 1. So everything goes over here, and I'm still looking for things that are greater than, so if let's say x was 4, right? X was bigger than 3. When I subtracted 2 from it, it ends up over here, right? Which is still bigger than 1, right? Or if I had, 10, if x was 10, which was another value that's greater than 3, and I subtract 2 from it, it ends up at 8, but that's still bigger than the 1. So this is still greater than, even though I'm subtracting, because I'm not multiplying or dividing by a negative number. So again, multiplying and dividing causes things to flip over 0, but adding and subtracting just slides them left and right. It doesn't cause them to flip, which is what's making the sign switch there. So let's do one where we do something like that. So what if I had 3 minus 5x is greater than, what do I want to do here? Like 2 plus 3x. All right, so let's have that. All right, so I'm going to get everything over to the left side first. So I'm going to subtract 3x. And notice that that does not cause my sign to flip, because I am not multiplying or dividing. I'm just multiplying or dividing by a negative number. I'm just subtracting. Then I'll subtract 3 to get that to the other side. -3 minus 3. And again, I'm subtracting, so don't flip the sign. Minus 8x is greater than -1. And then I need to divide by -8. Here I do need to flip the sign because I am multiplying or dividing by a negative number. Right? And so when these cancel, I end up with x. This over here is positive 1/8, and the sign turns over. So I want all the x's that are less than 1/8. So if I'm going to graph that on a number line, 0, it's 1/8 is really close to that. I'll just put it here. That's not very well to scale, but that's okay. Less than, so I want to not include that, shade to the left. And if I wanted to write that in interval notation, I would go minus infinity up to 1/8 and not include 1/8. So that's the other rule with inequalities that's different than equations. Mostly they're the same. The rule, you can add, subtract, multiply, divide. In fact, you can do anything you want to both sides of the inequality, just like you could to the equation. There's just the rule about, if the thing you wanted to do was multiply or divide by a negative number, you need to turn the inequality over. Other than that, the rules are the same, at least for solving. And then your answer is not just a single number. Your answer is an infinite set of numbers, right, that goes on from minus infinity to 1/8. And by the way, I should point out that something like this is also an infinite set. There's an infinite number of numbers between 0 and 2, right? All the fractions and decimals are in there. It's not just 0, 1, 2. It's like 0 and 1 and a half and a fourth and an eighth and a 16th and a 32nd, and the infinite number of things that are in there are all part of this interval. So when I say an infinite infinite number of solutions, that's not just because it goes all the way to infinity. Any interval has an infinite number of things in it. Yeah, so that's how you solve inequalities. You solve them just like equations, and then if you happen to multiply or divide by a negative number, you have to flip your inequality over. That's really the only difference. Now, there is one other kind of inequality that you end up solving a fair bit. So let me show you that. And that is something like this. Let's say I have not just x is bigger than something or x is smaller than something, but some expression with x in it, 1/3 x minus 1, is between, let's say, 4 and 1. Let's make this one equal to, just so we have a little bit of variety there. So here, I have a 3-piece inequality. This is saying not just that 1/3 x minus 1 is less than 4, or that it's greater than or equal to 1, it's saying that both of those are true at the same time, or 1/3 x minus 1 is between 1 and 4. And this is totally solvable, and here's the convenient part. It's just as easy as any of the other, the other types of inequalities. So here's how you do it. Instead of doing something to both sides of an equation or an inequality, you do something to all 3 sides. That's it. There's nothing else to worry about there. So what I want to do, again, let me remind you that we are doing SADMAP here. I'm going to write PEMDAS. But because we are solving for x, we are going this direction. So I want to get rid of the subtraction first before I get rid of this multiplication. So to get rid of the subtraction, I add 1, and I add 1 not just to the one side, but to all the sides. So 2 less than or equal to 1/3 x less than 5. And now I'm currently multiplying by 1/3. So the way to cancel that out, you can think of it 2 ways. You can think of it as either dividing by 1/3 or multiplying by 3, which are the same thing. Dividing by 1/3, multiplying by 3 are totally the same thing. I'm going to think of it as multiplying by 3. So I'm going to go 3 times, 3 times, 3 times, and so I end up with 6 less than or equal to x less than 15. So we get x between 6 and 15, and of course we can write that on a number line. I'll put 0 over here, and then 6, and then 15 will be like over there somewhere. And so I want to include 6 and not 15, and I want all the things in there, which tells me that I want an interval from 6 to 15 where I closed on 6 and open on 15, and that is my answer. Great, that's kind of all there is to that, right? Same exact process, just with, you're just doing something to all of the sides. So if you have something to do to all of the, or something that you want to do to peel off something that's schmutzing up your x, you just have to do it to everything. No big deal there. So let's do one more where we combine all of the stuff that we just learned. I'm going to throw in some negatives here as well. So if I have like -4 is less than, let's say 2 minus 3x, and that's going to be less than or equal to, what do I want to do here? It doesn't really matter, 17. Okay, so I'm going to do the same process that we did before. Actually, let me make this even worse. Let's do all this. Yuck, right? So now it's looking messy, but it's actually not really that much harder. We just have to do things in the right order. So the first thing to do here is to get rid of the 2. Excuse me, this 2 in the denominator. And you might say to yourself, well, hang on. I thought we were doing subtraction first. Why aren't we doing this? And the answer is this. Whenever you have a fraction like this, you can think of this fraction bar as being a grouping operator. So everything on the top of the fraction is kind of in parentheses. So that's actually the thing that we're going to do last, is try and get rid of stuff in the parentheses. We're going to get rid of all the stuff that's outside the parentheses first. So when you see a fraction like that, that's got like more than one thing in the top and more than one thing in the bottom, you want to think of those things as being grouped together like this. So the first thing I'm going to do is I'm going to look at this and say, okay, I've got some parentheses here and a division, right? And so I do division before I do parentheses because, again, we're doing SADMAP. So here's the D, and then the parentheses aren't way over there. So what I'm going to do is multiply everything by 2 to cancel out this 2. So I'm going to multiply -4 by 2 to get -8. I multiply by 2 here, and that just cancels this. And so that leaves me with 2 minus 3x. That's 34. Okay. Now we're back in the same situation we were in before, almost, right? So I'm just going to, now I'm looking at what I've got here, and I've got subtraction and multiplication. And since we're doing SADMAP, we do the subtraction. We get rid of the subtraction first. Although I kind of said that badly, because really this is a positive 2. The thing to remember about minus signs like this is that they're really on the thing after them. This minus is not on this 2. This 2 is a plus. The minus is on the 3x, which will be relevant in just a second. So to get rid of this plus 2, I'm going to subtract 2 from everything, right? From all three sides. -2, -2. Minus 10, less than, minus 3x, less than or equal to 32. And now I want to divide by -3 because I'm currently multiplying by -3, right? So I want to divide everything by -3. And as you may have guessed, that negative means that we need to flip over our sign. You might ask yourself, well, which sign? And the answer is both of them. Like, you have to do it to both. And we'll see what that looks like in just a second and why it's kind of funny to write things this way. But so the negatives over here cancel and I get 10/3. This sign flips over. -3's cancel, we get x. This sign flips over. And then I've got -32/3, which I'll just leave it that way. That's 10 2/3 when we want to put it on the, I guess I can say that, -10 2/3, so that it's easier to visualize for the number line, right? 32/3, who knows how big that is? You want to actually do the division and see what you get. So 3 goes into 32 10 times, and with 2 left over. So that's why this, and then just tack the negative on at the end. Okay. So I want to look at a number line for a second. And the number line I'm going to look at is going to have these things on it. So let's do this. So here's 0. 10/3 is over here somewhere. 10/3. And -10 2/3. So this is 3 1/3, right? So -10 2/3 is way over here somewhere. It's not to scale. -10 2/3 is way over there somewhere. So the reason it looks weird to me, I don't know if it looks weird to you, but it looks very strange to me to have something written left to right, but on the number line, it's right to left, right? This says that 10/3 is bigger than x, which is bigger than -32/30, right? So this says that x can be found to the left of 10/3, but I've written it to the right, which isn't wrong. Like, this thing I've done here is correct. It just looks really weird to me. I don't know if maybe you haven't seen enough of this that it looks weird to you. My students often see nothing wrong with this, but it drives me crazy. So in general, by the way, because small to big is left to right on a number line, almost everything gets written with less than signs all the time, right? Less than. A little hard to see here. Let me go look at this, right? Well, there's no inequalities here. Something like this, y is less than or equal to 0. Whenever you're writing something with 3 pieces like this, it ends up having all less than signs. And the reason is you want the small things to be on the left like they are on a number line. And if you do that, then you're saying that the things on the left are less than the things that come to the right. And so you end up using less than signs a lot more than greater than signs, because we read things right to left, or excuse me, left to right. And we have our number lines going left to right. And so less than signs are the natural relationship between left and right. Whereas greater than signs, like these guys, are not wrong. This is mathematically correct. It's just, it looks really weird, at least to me, because it doesn't go in the same order as a number line. And I want to think of this on a number line. So what I'm actually going to do is I'm going to rewrite it flipped over. I want to rewrite it with less than signs so that it goes with what I'm trying to say here. So this represents, the way I want to think of this is that x is between negative 32 over 3 and 10/3. It's between these two numbers, right? So what I'm looking for is all of this stuff that's between them. So my inequality that I'm going to write looks like this: minus 10 2/3 is less than or equal to x, which is less than 10/3, which is 3 1/3, I guess. I'll if I'm going to use mixed numbers, I'll use all mixed numbers. And so to me, this looks a lot better than this. And I understand if maybe that's not the case for you, but I like to write mine small things on the left, big things on the right, because that's the way the number line goes. And that's the way your interval notation should go as well, by the way. Always put the small number on the left and the big number on the right, because really what you're trying to do is describe an area of the number line. Also, I didn't fill in one of these. The negative 32 over 3 side gets filled in, so this guy should be shaded in. That's my bad. Right, and so if I wanted to write this in interval notation, I should do this: minus 10 2/3, comma 10/3. Don't include that. I don't know why I'm mixing mixed numbers with improper fractions. It's not wrong. It just looks a little funny. This is fine. And that's the answer. So let me just sum up. I know I was talking a lot and went off on a bit of a tangent in the middle there. When you're solving three-piece inequalities like this, where you have some expression for x is between two numbers, not just less than or greater than, then you have to you do your algebra the same. It's the same idea, right? Peel off everything that's not x. That's still what we're trying to do. It's just you have to do it to three things, right? So instead of doing it to just these two things, I have to do it to all three. And then if you do that, the thing you end up with is an inequality that says that x is between two things rather than just greater than or just less than. And so you have to describe it like this. Similarly, the rule about negatives still applies. So if you multiply or divide by a negative number like I did here, you still have to flip over your signs. It's just in this case, since I multiplied or divided, or in this case I divided by -3, to all three sides, I have to flip over both signs. And when I do that, it turns these nice, pretty less than signs into ugly, hideous greater than signs that describe things backwards. And so just a heads up, I will always write things like this. If you write it like this and then leave it, I won't like dock you anything or let you know that that's wrong, because it's actually right. But you will annoy every mathematician you meet if you do that. If you do this. So I will suggest that you write everything with less than signs to make it comport with a number line, right? You want this to be easily visualizable on a number line so that you get a clear picture of what your answer looks like. And I know that this is relatively simple and you wouldn't have too much trouble sort of mentally turning this around to visualize that. But things get more complicated eventually. And so it's probably a good habit to get into to do this. Everybody, my mathematician friends do this. I would suggest that you do it as well. All right. I think I hit everything I wanted to hit about solving inequalities. So two-piece inequalities, three-piece inequalities, interval notation, and the negative property of flipping things over. There is another property that causes you to flip things over, or that causes you to flip signs over, but I don't want to worry about that one right now. It's not going to come up. I guess I can't tease it like that and not tell you. If you take the reciprocal of something, it causes you to flip the sign over as well. But I'm not going to give you anything like that until much later in the course when we have rational equations. That's the first time it would ever come up. So we won't worry about that for right now. Just know that when you multiply or divide by a negative number, you have to flip the signs over. And I believe that is the last thing that I wanted to say. So I will go ahead and stop here. I'll stop the video here, and I guess I will see you guys in the next one.